Science! It's so exciting. I don't know, they just have these bit emojis that I find so funny. But anyhow, we're going to, continue on with some concepts that we were talking about last class meeting. And so, this limit definition as f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So again, like theoretical component is this represents the slope of secant lines. And as the secant lines are getting closer and closer and closer to the tangent line, that's what is representing the first derivative. And so the first derivative represents the slope of the tangent line. It also represents that instantaneous rate at a particular moment, or it was the growth rate or that rate of change. So those, concepts make good for true false. So then, we've been seeing in a couple of problems that, if you are on a restricted domain, such as the piecewise functions, then in order for the derivative to exist at some particular value, you needed to verify if the left-hand derivative equaled the right-hand derivative using the limit definition. But of course, I'm wondering, do I have to do this all the time? When am I going to have to use this taxing, long-winded, definition where I could usually, quickly use my, how do you say, the shortcuts. I always want to try to get this in the shortcuts. So what was here? So, that's, yeah, you should have questions. So the question is, when am I able to prove that a function f is differentiable at a? My question is, why do I need to use that long-winded limit definition or using a derivative rule? And my response is, well, it depends on the directions. So if the directions ask you to use the limit definition, then please do. If it doesn't, then you're able to use, we've already discussed 8 or 9 so derivative rules. We're going to add 6 plus another 3. We're going to add double the amount of rules. So that's why you have to listen to the directions. So, okay, we focused on, doing the definition of the derivative. We talked about, the difference between the position function versus the velocity function versus the acceleration function with respect to t. There's another component that, we cannot forget. And this is going to be hitting the books, because it's a big difference when your function is what? Discontinuous versus if your function is not differentiable. So, discontinuous would illustrate that the limit as x approaches a of f of x does not equal f prime of a. Then that's when f would be discontinuous. And then when you're talking about not differentiable, then that means that f prime of x equals the limit as x approaches. No, wow. You see, that's what we want to do, and then I have to go back. This is the day when I had to use whiteout. However, it is the as h approaches 0 of f of x plus h minus f of x all over h does not exist at, I don't know, some value, right, that equals x. So there's a difference in that particular notation. And this is like, explaining. So I could say, after you're studying, are you able to provide a verbal, verbiage of what it means for f to be discontinuous versus what it means for f to be not differentiable. Oh, wow. Yeah. So then not only, did we do all of that, we talked about a bunch of rules. And, this is the thing where Dr. Krennic, used to remind me that, if you forget, you write them out, So that's why, it's long-winded, but the derivative of the function with respect to x of a constant was going to be 0. The derivative with respect to x of a constant times f of x, that was going to equal c times f prime of x. Then we said the derivative with respect to x of x to the n minus, I know. Oh, that's a mistake. I don't have edits, so it's fine. Of x to the n was going to be n times x to the n minus 1. What else did we say? I know it's a lot, but this is how you keep track. The derivative with respect to x of a product of two functions was going to be, I don't know, the first times the derivative of the second plus the derivative of the first times the derivative of, times just a second, sorry. And again, this order wouldn't matter. And then we talked about the derivative with respect to x of f of x all over g of x, which was going to be the low function times the derivative of the high function minus the high function, no, rewind. So let me just restate this. The derivative of the low function times the derivative of the high minus the high function times the derivative of the low function, which is going to be all over the low function squared. And we said that the critical values occur when f prime of x equals 0, or we said f prime of x equals undefined. And that's the drill, right? So I just did a 9-minute recap of things that I should have, drilled pre this. And then what happens is that, say, what? We're going to talk about more stuff on top of that. So, this is the thing, that our time now is going to be so quick with some intense information that we just got to make sure that we are drilling so we don't fall behind. And then we'll pick up on what are we going to do next, huh?